Hello students, how are you? Now we are going to discuss about sequence and series. In sequence and series, if you remember, there were so many puzzles and so many Olympiads that we used to solve it out, and there was science Olympiad, maths Olympiad, English Olympiad in your previous classes, and you were to just guess it out that these puzzles or your mental maths questions, what they are actually are and how you are going to solve it out. Now, in your class 11, when you are going to learn each and every puzzle or each and every mental maths question in detail with reason, then you're going to understand that what your teacher used to explain it to you was nothing different, nothing so difficult that you were not able to solve it out at that point of time, but now you can. The word progression explains to you that that is your progress, you're increasing, you're decreasing, how your progress report was in your FAs, in your other things. Progression means improvement, increase or decrease. So, a sequence following some definite rule is called a progression. For example, 2, 5, 8, 11 and so on. Here it is addition of 3. 2, 4, 8, 16, so on. It is a progression of multiplying the digit by 2. 1, 1 by 3, 1 by 5, 1 by 7 and so on. So now we are going to discuss about series. If the term of a sequence are connected by a plus or minus sign, a series is formed. That means in progression, as I just told you, that if you are having a sequence with a definite rule, it is called a progression, and if the same sequence are connected by a plus sign or a minus sign, then we call it as series. For example, 1 plus 5 plus 9 plus 13 and so on. Similarly, 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 and so on. Same way, 1 plus 1 by 3 plus 1 by 5 plus 1 by 7 and so on. In this, it is connected by a plus sign rather than a comma. The word arithmetic in itself explains either addition or subtraction, and the word progression means progress, improvement, and any sequence that is having a certain progression by the addition or subtraction, it is called an arithmetic progression. So let's discuss a finite or infinite series or sequence A1, A2, A3, so on till AN is said to be an arithmetic progression if AK minus AK minus 1 is equal to D. A constant is independent of K for K is equal to 2, 3, so on till N as the case may be. Here it is either finite or infinite. Finite means you can count the number of variables, and infinite means it is uncountable number of variables over here. The constant D is called the common difference of the arithmetical progression. Here D, just remember it is AK minus 1. That means the next term minus the previous term, and the difference between both is common, and that is constant throughout the sequence. For example, 12 plus 10 plus 8 and so on. Here is the constant, that is the common difference, is minus 2. 5 plus 2 minus 1 plus 4 minus so on till 22. There is a difference of minus 3. Now comes sum of n terms of a given AP. When you are going to find out the sum of n terms, that means it's a finite sequence, and you are going to find the sum of your arithmetic progression. Let A be the first term, D be the common difference, and L be the nth term of a given AP. L is equal to A plus n minus 1 d. Considering this as equation number 1, let Sn is equal to a plus d, a plus 2d, so on, L minus 2d plus L minus d plus L, putting this equation into equation number 2. Writing right hand side of Sn in reverse order, we get Sn is equal to L plus L minus d plus L minus 2d and so on, a plus 2d plus a plus d plus a. In this, if you just look at this sequence, L was your last term and the previous term will be L minus d and the previous to that will be L minus 2d. So considering this, we have written in sequence and then in the reverse order, and putting this equation to equation number 3. Adding 2 and 3, we get 2Sn is equal to a plus L plus a plus L plus a plus L, so on till a plus L plus a plus L plus a plus L. So this comes out to a plus L, a plus L, a plus L till n terms. So 2Sn is equal to n into a plus L. So Sn is equal to n by 2 into a plus L. So the value of sum of n terms comes out to be n by 2 into a plus n minus 1 into d. Putting the value of L, we get n by 2 into 2a plus n minus 1 into d. We are not knowing the value of last term. We can use this formula to find out the sum of n terms of a given AP, that is n by 2 into 2a plus n minus 1 into d. Now, taking an example of this series, 72 plus 70 plus 68 and so on till 40, we are given the first term as 72, last term is 40, and we don't know the number of numbers in this sequence or in this series. The given series is 72 plus 70 plus 68 plus so on till plus 40. Here a is equal to 72, d is equal to minus 2, L is equal to 40. Now L is equal to a plus n minus 1 into d. 40 is equal to 72 plus n minus 1 into minus 2. So 40 is equal to 72 minus 2n plus 2. So this comes out to be 2n is equal to 34. So n is equal to 17. So the required sum is equal to Sn is equal to n by 2 into a plus L. Putting the values, that is 17 by 2 into 72 plus 40 is equal to 17 into 56 is equal to 950. Let's discuss how to insert NAMs between A and B and also show that the sum of NAMs between A and B is n times a single AM between A and B. Let A1, A2, A3, so on till AN be NAMs between A and B. Let D be the common difference of this AP. Now A is the first term, B is n plus 2th term of this AP. Now if you just look at this A and B, A is your first term because you are introducing n names between two numbers. No? So A will be considered as the first term and B will be considered as n plus 2th term. So this gives you the value of B is equal to A plus n plus 2 minus 1 into T. B minus A is equal to n plus 1 into T. Therefore, D is equal to B minus A into divided by n plus 1. Now, A1 is equal to A plus D. Putting the value of D over here, we get A plus B minus A by n plus 1 is equal to An plus A plus B minus A by n plus 1 is equal to An plus B by n plus 1. Now, taking out the value of A2 is equal to A plus 2D is equal to A plus 2 into B minus A by n plus 1 is equal to An plus A plus 2B minus 2A by n plus 1 is equal to n minus 1 into A plus 2B by n plus 1 and so on. An is equal to A plus Nd is equal to A plus n into B minus A into n plus 1 is equal to An plus A plus Nb minus Na into n plus divided by n plus 1 is equal to A plus Nb by n plus 1. So, the sum of n AMs between A and B is equal to A1 plus A2 plus A3 so on till An, that is equal to n by 2 into A1 plus An. Here we are talking about the using that formula sum of n numbers of an AP where sum was n by 2 into first A plus L, so A1 plus An. So putting the values of A1 and N over here, we get n by 2 into A plus D plus A plus Nd is equal to n by 2 into 2A plus D into n plus 1 is equal to n by 2 into 2A plus B minus A by n plus 1 into n plus 1. So the value comes out to be n by 2 into 2A plus B minus A. Solving it out, we get n by 2 is equal into A plus B. So n into A plus B by 2. If you just figure it out, A plus B by 2 is the value of AM. So sum of n AMs between A and B is equal to n times single AM between A and B. Don't forget to like, share and subscribe my channel and be regular with my videos so that you can get to know more informative videos and more about the sequence and series and more lessons. We will follow it with our sequence. So take care, stay safe, stay healthy.